An ionic compound. Who can help us out? What is an ionic compound? Aiden? What's an ionic compound? Anybody help them out? Okay, they're salts. What else?
They're compounds composed of ions held together by electrostatic forces.
Very good. So they're compounds composed of ions. Now, if you're an optimist, you might remember which ion first. Yeah, you're a cation, you're an optimist. So the cation has a positive charge. And if you are a pessimist, which would you remember first? The anion. So, I mean, it's a lot of how you view the world. I mean, some people just see everything negatively. They're like, oh, this is negative, and they'll just tell you all these negative things. And you're kind of like, okay, this person is a pessimist. It's okay. I mean, I'm just saying, you might want to remember, if you're a pessimist, you might want to remember the anion is what? Negative. Then you got the cation, because you got half of them. All you got to do is remember half, you get the other half. Now, what goes first, the optimist or the pessimist? Optimist. The optimist goes first. Very good. Okay, so in your notes, we want you to draw table 7.1 again. This is probably the third time we put the electron dot structures in your notes, because you're going to see them again next semester, and we want them to be in your brain as far as structure is concerned. You'll also see them on certain tests. They might ask you to draw the electron dot structure for an ionic compound or for a molecular compound. So the main group, these 8, are the predictable ones in the periodic table. That's why we should know them. So draw those. It's about a minute. 7, we're going to draw the positive ion. So if you're the optimist, you'll know very much about the cation. The optimists typically like cats too, because cats are not always easy to like, because they jump all over the place and they go into the toilet. They like jump in the toilet. You got to keep your toilet seat down. And then they'll jump on your countertop. Yeah, we had a cat once, and we had to like abandon the cat to the shelter because it was just too much to deal with. Actually, our neighbor took it over. We loved the cat. Her name was Tiger. And the coolest thing about her was that she would kill stuff in the neighborhood. She'd bring it back to our front porch. Like, she'd kill squirrels and rabbits. I mean, just the dead carcasses up on the porch. Yeah, she was a killer. She was ferocious. So you have 11 protons and 10 electrons. That gives you that overall positive charge. So that's a metal. Metals lose electrons. We introduced electron configurations. You can see there in the book on page 209 for chlorine, argon. So they're showing it to you for the chlorine ion. It gains an electron, so it's 3p6. So why do we care about electron configurations? Aiden? They help us understand the behavior. So chemistry is really a study of the behavior of the elements, about periodicity. Periodicity is really all about the electron. What's the behavior going to be? Can we predict that? If we can, then we can save money and save time. So understanding the electron configurations will help us know where the electron is. Now, behaviors are typically associated with what? Nicknames. So the electron configuration is kind of a nickname. So chlorine's nickname would be 3p5, because the last electron configuration given is really going to tell you a lot about chlorine, especially if it's a main group element. So nicknames in life, a lot of people will change their names based on their behavior, like Cassius Clay became Muhammad Ali based on his behavior, not really his looks. I mean, things happened to him, and that's why he changed his name. I'll give you another example of somebody who's changed their name based on behavior.
Lady Gaga. Yusuf Cat Stevens.
Okay, Yusuf Cat Stevens. Lady Gaga, somebody said. There's also, like, who else? Prince. There was this guy named Saul. He was going around killing people, and he changed his name to Paul. I'm just saying. So people will change their names in life based on various things that may happen to them or behaviors that they experience. Now, I don't have any plan on changing my name. I'm just saying, but Hunter probably does. He's probably going to be... What are you going to change your name to, Hunter? He's going to change his name to Fisher. Because he's probably going to be a fisherman one day instead of a hunter.
Archibald.
Is fishing hunting?
Archibald. It's going to be Archibald.
Do you archery? You shoot?
I wanted to, but I don't have means of transportation.
Okay. Then if you do, then you would be a hunter. So you can keep your name. You figure with 7.4, the neutral chlorine ion, correction, neutral chlorine atom that gains an electron, becomes the ion, larger in size.
Leave it alone, Hunter.
Sodium and chloride. Magnesium oxide, the reaction product is shown, magnesium oxide, the reaction product is shown in figure 7.5b, is also a binary ionic compound.
Okay, so how many substances are in binary ionic compounds? Let's go with Laurel. You don't know? How about Claire? 2. Very good. Binary means 2, so you have 2 substances in binary ionic compounds. In the lab we're going to do on Thursday, we're going to burn some metals, and the difficult part will be identifying the unknowns. I'll probably have 5 different unknowns that you'll have to identify. You basically will be burning ionic compounds because the ionic compound has the salt in it as the ion, and it's just easier to have the surface area. Like when you are burning wood, if you chop the wood up, you get a better fire. So the ionic compound provides greater surface area for you to see a color associated with the electron transition. So we'll talk about that on Thursday. So we'll go over the quiz tomorrow. The quiz will be the basis for your test on Friday. So we're going to continue on in the book about compound formation and charge. Who wants to read for us? Page 211. Pick somebody. Who's read? Oh, Ben, pick somebody. Transferred to the nonmetal. You have Na as a positive representing the pseudo structure, the pseudo noble gas structure. And then you have the chlorine with the negative plus energy. The energy would be like if you drop sodium in water, it explodes. That are formed, right? That means that are being lost and gained electrons are. If I have a positive hydrogen and a 2 negative oxygen, are those 2 balanced? I have a 1 positive hydrogen and I have a 2 negative oxygen. Are those 2 balanced? No. 1 positive does not equal 2 negatives. Is everybody clear? So the question is, what do I have to do to get both of those balanced? So this is 2 positive, this is 2 negatives. Does everybody see that? So the common denominator between the 2 of them is 2. Does everybody see how that's the common denominator? So if I add another hydrogen, then I have 2 of these here, right? So this ends up being 2 positive, and this ends up being 2 negative, and then I have an overall charge of 0. All compounds have 0 charge. I'm going to write that down. All compounds have 0 charge. That would be 0. 0. Any question on that? Now, for example, over here, we have Al3 positive, O2 negative. So what's the common denominator? Laurel? All right, help her out, Kennedy. I have 3 positive and 2 negative. What's the common denominator? Anybody help her out? What number will go into both of them to get the same number? Yeah, 6. So this 6 is the common denominator. Lowest common denominator. You could do the highest one, but I would recommend the lowest. So I need to get to 6 here. So what am I going to do with the Al3 positive? I'm going to add another one. This is why it's H2O. That is this right here. This is going to be H2O. You have 2 hydrogens and 1 oxygen. So all your life you've heard of H2O, right? Now you know why it's H2O. So over here, what do I need to do with the oxygens? I have to add 2. Now there's a cut and paste activity we're going to do tomorrow that kind of reinforces this concept. So I have a 6 positive here and a 6 negative here. Does everybody see the charges equal 0? So what's the formula going to be? What's the formula going to be, Aiden? What's the formula for this going to be? You're on the right track. Al2O3. So this is going to be Al2O3. It's not really that difficult. When you have 3 here, 3. To try to keep it kind of where we can explain it. Common folk like myself.
Ions produced as a highly ordered cubic crystal, as in all ionic compounds in NaCl. No single unit consisting of only 1 sodium ion and 1 chloride ion is formed instead of large numbers of sodium ions and chloride ions exist together. If you can obtain a magnifying lens and use it to examine some crystals of the table salt. What is the shape of these small salt crystals?
Alright, so you can see those right up here on the ceiling. This would be the sodium chloride table salt cubic crystal structure. Kind of looks like this. You can see it's similar in the book. The book does a better job of showing it in the green here. You can see how the cubes. The chlorine obviously are going to be inside. There's correction, the sodium is the smaller sphere, and the chlorine is the, I guess, the green sphere. So this would be the chlorine, and then the sodiums would be inside of it. Structure. So if you turn the page on 214, you'll see a lot of different cubic structures. You can identify the salts by what particular structure you see. So we can take some like copper sulfate, put it in water, and then grow salt crystals. You ever remember doing that when you were younger? They had little salt crystals you could draw on the aquarium tanks. Well, you can put those under a microscope and you can then identify the salt based on the crystal that it grows. So that's kind of neat as far as like identification of unknowns. You can use the crystal structures. They stopped giving the salt tablets. Well, the blood pressure can rise too quickly, and somebody might take too many salt tablets, because you know some people just don't follow directions. You're like, hey, you only need to take 1 of those. Somebody might take 4, and then you can raise their blood pressure and they can pass out. So it's much easier taking the electrolytes, that would be the salt, and dissolving in water, and now you have what? Gatorade or Powerade. So they're trying to control the electrolytes a little bit better. But even then, I mean, some people, they lose so many electrolytes that they're not replenished quick enough, and you might have to take some salt supplements. But salts are a very important part of your diet. If you don't get enough of them, they can make you sleepy. One of the side effects is not getting enough salt. Because what does salt do? I mean, it raises your blood pressure. So if you have a high blood pressure, you're not going to want to be sedimentary. You're going to want to like, I got high blood pressure. I got to do something. You know, you'll know if you have a headache. You ever had a headache? That's kind of similar to having high blood pressure. You know, you're kind of like, got to do something. Calm yourself down. And then your Tylenol typically lowers your blood pressure, thins your blood. Make sense? It's a blood thinner. Aspirin is a blood thinner. All right, so let's read a little bit about the electrolytes. Who's just read? Pick somebody. Oh, Aiden, go ahead. Pick somebody, Aiden. oftentimes, like if you're playing a sport and you're playing it very intensely, you can get lightheaded. Why is that? You might lose some of your electrolytes, and what else might you be low on? Sugars. Your brain runs only on sugar. So if you've been working really hard, and then you're kind of like because you're thinking a lot of sports that require a high level of thought can drain you pretty quickly. Specifically like football and soccer and any sport that you're going to think a lot. Some people think a lot just in general. I mean, they constantly think. I was watching this Bob Newhart special, and he was talking about people who think a lot and they think about negative things. This one woman thought she was going to be buried alive, and he told her just to stop it. Some people just think negatively all the time. They're kind of like pessimists. So that requires a lot of sugar. The whole point there is that there's a balance between the sugar and the electrolytes in your brain. So if you're diabetic, you might not be able to check that sugar low level in your brain because the brain runs only on sugar. If you didn't know that. It doesn't run on like fats or protein. It's sugar fed. So the brain is not normally tied with the blood flow through your body. Does that make sense? Blood does flow to the brain, but it just flows there in different amounts. Just not exactly, tied to your muscle blood sugar. Your blood sugar in your blood. Element 1, which is sulfur. And you have element 2, which is hydrogen. Now, in your book, on the back of the book, they show you a table, periodic table. It's color-coded. The yellow is what? The yellow shows you here that it is a nonmetal. You can see here it says nonmetal, recently observed is the bottom, metal is blue. So the yellow is the nonmetal. So you can look at this table to determine what these substances are. Sulfur is a nonmetal, hydrogen is a non. And is it going to be a salt or a molecule, Grace? It's going to be a molecule. Nonmetals are always molecules. Now, if you have a copper, which is a metal, right? I'm doing the last one. And you have sulfur, which is a nonmetal. So I'm doing the first and the last one on the chart. Is that going to be a covalent or ionic?
Ionic.
It's going to be ionic. So you can see the difference between the two. That's the only two types on this chart. And the last one, is it going to be a salt or a molecule?
Salt.
It's going to be a salt. Now on the bottom, the second chart, we need to look in your book on page 194. So you turn to page 194, page right here. So I need to find what the value is for carbon. What's the value for carbon? It says 2.55 is carbon. So I want to put 2.55. Does everybody see where I got carbon is 2.55? On page 194, there's a electronegativity table. What's the value for chlorine? 3.16. Now I need to take 3.16 minus 2.55. What does that equal? That's the difference. It equals 0.61. Now I have to find on this chart that I gave you on this handout, I gave it to you because I'm a nice person. You'll see that 0.61 does not fall between 0.0 to 0.2, so it's not going to be nonpolar covalent. It falls between 0.3 and 1.4, so it is polar covalent. This is polar covalent. Now what does that mean? There's two possibilities. It's either going to be like water or it's going to be like what? If it's not like water, it's like what? It's like oil. So if you're nonpolar, you're like oil. So oil and water don't mix because of the polarity. Polar is like a magnet, nonpolar is not like a magnet. So that's what it means by polar and nonpolar. Polar's like water. Non-polar's like oil. Now, if you like oil, then you remember the nonpolar. Some people like oil. I like water, so I'm going to remember polar.